So I think we can start with the afternoon session. Okay. One quick things, please. You have to sign also the documents, okay, for the participation to the SeCure meeting of this afternoon, not only the one of this morning. Okay, so I think that now they make the shit moving between the people. Okay, so I think. So I think we can start. Okay, so as you can see, so this afternoon we will have the kick-off event of the SeCure project. You have the time table of this event, and you can see here we will have at the beginning a greetings from the managing authority of the Italian-Croatian project that is provided by Dr. Anna Flavia Zuccon, that she is here. As you know, this afternoon we will move completely through English, so there will be no more need of translation. We will all the intervention will be provided in English. Okay, so let's start. I'll give you the microphone also.
Give my greetings, stand up, because I'm not so tall. Maybe that you don't see me later on. I'm joking, of course. Good afternoon, I'm Flavia Zuccon, and I'm the managing authority of this program just from July of last year. So I'm a new managing authority, but I'm very pleased to be with you today. And I'm very pleased first of all, to be here for a cluster project, because I remember perfectly that the call was closed in the middle of December last year. So to have the kickoff meeting 6 months later is really a success. So if a project starts with a success step, we can imagine that also the future steps will be successfully done. So, I wish to remember to you how we arrived to this project. The monitoring committee of the program decided, and the managing authority did, to allocate the last financial resources of the program on a kind of experimental initiative, and the so-called restricted call for project proposal, and these were the 4 aims. Of course, to maximize the experiences of the partners which already are working together in other projects that were already financed by the program, in order to perfectly exploit the result that they have achieved till now. We need, by these cluster experimental projects, to have the possibility to share our common knowledge, not only in the content of your project, but also in the cooperation and in your ability to work together. These could allow synergy, not only among the projects, because a cluster, of course, regroups grouped different projects and different partners, but also to promote synergies possibly with other Interreg programs. At the end of this exercise, with the monitoring committee, we identified 5 different thematic areas. But first, to go to the thematic areas, I wish to underline what we want from you. So the main expected achievement of the cluster project is just this. Innovation, because it is true, we grouped previous projects, but we need that the cluster project gives some innovative solution. The transferability of the result of the project in other possible, with other possible partners inside the area. The possibility, as I said before, to work with other projects financed by other Interreg program, but also to be in line and coherence with the macro strategies for the Adriatic and Ionian development, the so-called USIRE strategy. And, of course, to put together your ability to be good communicator and disseminator of these experiences and of the result of the project. We imagine the cluster project as a kind of bridge from this programming period to the next one, and this is the reason why we asked to the proponent of this cluster project to have a look to the USIRE flagship and to the possibility to give the result of the project to the policy makers who are thinking to the next programming period. Really, just in a scheme, the 5 cluster thematic. And in green, of course, your specific thematic, but in the scheme you can find also the coherence with the pillar of the macro strategy USIRE, with other cluster project financed by Adrian, that is our flagship program, because it's the transnational program insisting in the same cooperation area. And we need to have this program as a light in our work. And also in the last part, in the right part, the column with the coherence of this thematic with the new specific objective that we put inside the IP, the Interreg program draft proposal for the period 21-27. This scheme is relevant to understand that all 5 thematic clusters can contribute with their project to the next project that will be financed by these priorities, by the priorities that are in the new Interreg program. You know maybe perfectly from where you go. Your roots are 3 other projects. We grouped these projects because each of them already discussed inside the partnership different aspects of the current SeCure project. As there is, I hope that this is the right title, not asterisk, which was dealing with the assessment, the theme of the assessment and the needs of the barrier to fight the risk management. Most that we perfectly know, you have a meeting in this morning, so it was the final conference and the results are perfectly known. Most is dealing with the possibility to monitoring. So, Asteris for a common assessment tool. Most for monitoring in a concrete the situation, and change we care, the third of the project that we combined in this cluster, was dealing with the possibility to involve the citizen, to involve the population. So this is another really relevant task of each of Interreg projects. The task is to be visible, to be useful, not only for the partnership, for the technicians or the expert sector, the aspect of the sector, but also for the citizen. So, following the logic of this restricted call, we hope that the result of SeCure could be useful also for the next programming period, the next IP Interreg Italy-Croazia, and in particular for the priority under the objective 2, that the European cohesion policy dedicated to greener Europe. The coherence of your project, so, is from the current programming period to the next programming period. Why? Because you can, with this project, with your cooperation in the content of the project, go towards a more active, a proactive approach to the next objective 2 of the European policy for the next programming period, towards what you can see here, greener, low-carbon transition, but not only, also to be, to reach a more resilient Europe, promoting a different energy, a different use of energy resources, insisting on green and blue investment, the circular economy, but also, and that is relevant for this project, for the mitigation from the climate change effect. In Italy, the effect of the scarcity of water in these weeks is really relevant. So we can say that this project is really up to date, how can I say. So, in another scheme, this is the last slide and the last scheme, the new strategy for the next programming period. We proposed to the European Commission at the beginning of March our 5 priorities. Each of these priorities are connected with 5 policy objectives that are in the European regulation for the policy for cohesion. So the first one, inside the theme of Smarter Europe, is dedicated to the sustainable growth in the blue economy. The specific objective that you find in the right part of the slide are 2. This meaning that the project will be devoted to research and innovation, in specific under the blue economy definition, but also with the specific objective 1.4 will be dedicated to reinforce the skill and smart specialization in this blue economy sector, in this blue economy environment. Skill for entrepreneurs above all. The second priority is inside the objective that we already saw, the Greener Europe, and we choose inside the task force of the program a specific, the two specific items dedicated to climate change adaptation and disaster risk prevention, and also to the protection of nature and biodiversity, and to the reduction of pollution in very general sense. The priority 3 is a confirmation, and it is dedicated to the maritime, but not only, also the multimodal transport system. The fourth one is more new in respect of the current period, is dedicated to a more social approach, a more inclusive approach of our project. Even if the themes are not new for us, because they are anyway, the culture and the cultural resources, the cultural heritage and the natural heritage has a leverage for the development, and in particular using touristic destination. But we have to remember that we have in mind an inclusion, a social approach to this kind of projects. Last but not least, a specific objective for Interreg. ISO 1 is the title, and the meaning is to reinforce again, even if it is the fifth time for Interreg, we need to reinforce anyway the cooperation among all the level, administrative level, economics level, research level, and also civil society level. There is not a big budget for this priority because it's new and it's a specific priority of Interreg. But we expected really significant result also from this priority in order to make partnership agreement, common plan, common way of the governance of our common sea. So it is not so big, but is really challenging, and it is really the aim of Interreg as such, because it is the objective for the better cooperation governance. I put a kind of stamp in a blue box. Digitalization and circular economy. Sorry, the words are cut, but these are two cross-cutting issues. What means that each project has to be inspired to these kinds of action inside of the project, independent of the priority in which you will put your proposal. So, the area of cooperation remains the same also for the next programming period. All the Italian Adriatic regions and all the Adriatic conteas of Croatia will remain the same. Regione Veneto will be the managing authority also for the next programming period, and we will have the support as now of the JS, the Secretariat, Joint Secretariat, a part of this secretariat is in Venice, and we have really, how can I say, really a concrete support from the JS. And another part, also relevant and important, above all for a first contact for our Croatian colleagues, is in Zadar. Thank you for your attention, and please do listen for me the next part of the seminar.
Okay, thank you a lot, Dr. Zuccon. Really nice talk, and we hope, and it's very important for us also to see this possible future programs. So I hope that we will be able to perform very well during this cluster, let's say, call, in order to start also, and to start from, let's say, a well position for the next program. I think this is very important for us. So thank you a lot. So we can move on, okay? And as you can see in the program, I will now it's my 10 minutes talk. Quite quickly, I will make a sort of short review about short summary about our SeCure project, which is the starting point and what we expect to obtain. So I'll move to the other microphone. Okay, so yeah, today is this kickoff event, okay, and something that has been just said, so which is our starting point. First of all, what means SeCure? Because it's an acronym that someone does not like too much, right, Valentina? But it's what we were able to find at the end. So the full title of this project is this one: Saltwater Intrusion and Climate Change, Monitoring, Countermeasures, and Informed Governance. And the starting date is officially May the 1st this year, and we will end at the end of June of the next year. Dr. Zuccon has just said that our project is located within this cluster project number 2, so adaptation to climate change, governance and capacity building, and specifically our objective is improve the climate change monitoring and planning of adaptation measure, tackling specific effect in the cooperation area. Which are the partners of our project? Let's say they are listed here. So the leading partner is again the University of Padua, our Department of Civil, Environmental and Architectural Engineering, so the acronym is ICEA in Italian, and Paolo Salandin is also for this project, let's say the reference, the leading partner, the reference for the leading partner. I will help as project manager. I will help him as project manager of this partner. Then we have 6 project partners. 2 of them are Italian ones. So again, the Institute of Geosciences and Earth Resources of the Italian National Research Council as PP1. Then we, as PP2, we have the Soil and Coast Defense Directorate of the Veneto region. And then we have 4 Croatian partners. The third one, 3 of them let's say, we know already directly because we work together in MOST. So the Faculty of Civil Engineering of the University of Split. Then we have the Regional Development Agency of the Dubrovnik-Neretva region, DUNEA, as we know more easily. We have PP5 that comes from a project that it is outside MOST. Here you have, on the right-hand side, we have the table of, let's say, the original project where the different partners worked in the Standard-Plus project. We have so PP5 is the public institution for the management of protected natural areas of the Dubrovnik-Neretva county. And then we have the Croatian Water, the Department of Water Resources. So six partners plus one leading partner. And we are more or less, let's say, share and half. So 2-3 partners from Italy and 4 partners from Croatia. I summarize I just copy some of the lines that we wrote in our proposal, relatively quick, but just to make aware to everybody, which are, let's say, the objective of our SeCure project. So the first one is the characterization of the process of saltwater intrusion under the effect of climate change in the Adriatic low-lying coastal zones of both Italy and Croatia. And then not only characterize, but also proposing best practices in order to facing this scourge. And of course, we need to play with governance and capacity building in order to maximize the main outcomes of the experience developed during the Standard-Plus project. And as has been just said, in order to, let's say, to develop and improve synergies between the different projects and between the results that we have obtained in order to enhance visibility and transferability. The project is, let's say, is made, if we want, of 3 or tackle three specific objectives. So the first one, if we want, is let's say the more technical one, we can say, so we want to take advantage of this further year in order to continuous monitoring and to use the monitoring system and the monitoring network that has been established during the Standard-Plus project. This is for just an example, but it is very important. For example, we know for our pilot site close to the Venice Lagoon, in order to test the reliability and the applicability and the effectiveness of this drain that we put in order to recharge the farmland with fresh water. The second one is, and this is also related to the second, okay, the second topics or second specific objective, so testing the countermeasure, that we have put in place or we have, let's say, planned during the Standard project. And then the third objective is a comparison and integration of the different experiences that we developed during the previous Standard project, allowing to upscale guidelines that has been, let's say, previously developed mainly at the local scale in a more wide and more general to a more general point of view. Which are the sites of the SeCure project? If we want, they are more or less the same, of course, as in the previous one. So we will focus our attention on the Neretva plain, because this is, for the Croatian side, if we want, is one of the, or probably the only one, very flat plain or low-lying plain that it is located along the Croatian coast of the Adriatic Sea. about the Italian site, we will put the focus on the site that it is located, let's say, at the southern part of the Venice Lagoon, but the idea is to play on a more wider, let's say, this should be only, let's say, one specific point of a wider area, because all this area highlighted by this dashed line is more or less in the same condition from the point of view of salinization of shallow aquifer and farmlands. Steps. So we have three steps, and one very important is the secure communication. So a high-level communication plan will be developed, and we will work a lot with the JS about this, because this is really very important for this cluster, for the cluster program and projects, and so there are already some meeting already planned between our partner and the JS, specifically related to how to programming and how to developing the communication aspects. Then step 2 is the most technical one, let's say, so tuning the countermeasure that we, and the previous experience that we had on the farmland and on the sites, in order to improve and verify their efficiency. And the third one is more related to governance, so increase the validity or the generalization of the guidelines that we have developed during the specific Standard Plus project in a more wider area, wider way. The work plan of the project is something that it is relative, I would say, strict. So it was something that the JS forced us to follow this. So we will have a WP1 work plan or work packages that it is mainly related to the management of the project. We will have a WP2, a work package number 2, that it is mainly related to the communication part, and we will have, let's say, a work package number 3 that it is mainly related to the application or to the more technical scientific aspect, but also related to the contribution to the next programming period and arising awareness about this problem. To conclude, which are the target groups? As communication is so important, we have, of course, be very well aware which are our target groups. And we detected when we developed the project, the proposal, we detected the four target groups. The first one is the general public. Okay, so general public, that means also general citizens, farmers, people that has some that works and stay and live in the area. And the main means to involve them and to communicate to them about SeCure project and the outcome that the project will produce are to project website, informative events, and social media. Then we have the local, regional, and national public authorities and related entities. Okay, so let's say the authority that has jurisdiction on land planning and water management and agricultural, let's say, agricultural issues, and, for example, also the management of natural environment. And the idea is to involve and to inform them through production of technical informative documents and the organization of study visit and event on the sites. Then another important part is related to education and training center, and our idea is to focus this target group mainly with students of secondary and high school in the region facing the northern Adriatic Sea, in Italy and Croatia. So the idea in this case is to develop some, I would say, technically correct, but not really difficult from the scientific point of view, but something that it is really informative in terms of flyers or PPT presentation, or also to propose some lecture, for example, that we can share with the students during their, for example, science courses. Last, but not least, of course, are university and research institutes. And this is, of course, something that we will, as university, this is relatively simple for us because we will, let's say, inform and link them to our project through publication, conferences, presentation, and through development of a web page and also something related, for example, in ResearchGate. So some specific, let's say, means that we currently use every day. Okay, and I'll stop with this. So this is just a quick overview of our SeCure project, which are the objective and which are the means that we want to put in place. Okay, then then with Valentina we have the idea just to be aware what these three SeCure projects are. We have the idea to summarize very quickly the result of the Standard Plus project using the videos, 3 short videos that each program has developed in order to summarize everything into 10 minutes. Okay, so let's start from this one that probably, or for sure, you have already see this morning, but let's restart again. But we need audio, so let me...
And how does it affect coastal plains? Saltwater intrusion is a natural phenomenon caused by the advancement of marine water from the sea and lagoons towards the inland, along river mouths and in the subsoil. This phenomenon results in the salinization of soils and aquifers, damaging agricultural activities and coastal freshwater resources. The combination of sea level rise, drought periods, and lowering of the ground elevation caused by land subsidence amplifies the extent of saltwater intrusion with irreversible effects. Along the Italian and Croatian Adriatic coast, large areas are severely affected by this phenomenon, reducing freshwater availability and agricultural productivity. The MOST project, developed within the framework of the EU Interreg Italy-Croazia programme, has identified 2 study areas on which to conduct in-depth investigations and monitoring. These are the 2 coastal areas dedicated to agriculture. In Italy, we are on the low-lying plain just south of the Venice Lagoon, near Chioggia, at the mouth of the Brinta and Bacilone rivers. In Croatia, we are on the delta of the Neretva River, which is located in the plain between Split and Dubrovnik. The phenomenon of the saltwater intrusion can extend tens of kilometers inland. For example, in the Italian study area, this map shows the most vulnerable areas in orange and red colors. As part of the MOST project, sedimentary cores, geophysical surveys and monitoring of groundwater and surface water parameters were carried out, providing a significant step forward in our knowledge mechanisms driving saltwater intrusion and its dynamics. All the collected data allowed the development of mathematical and physical models to better understand the evolution of the phenomenon and to better design appropriate experimental measures to mitigate salinization. As can be seen in the Chioggia area, we built an infrastructure that takes fresh water from a canal and releases it through a sub-irrigation pipe along a sandy paleochannel. This experimental form of irrigation was then subjected to a hydrological and agronomic monitoring. Are you wondering what the results are? Close to the sub-irrigation pipe, fresh water spreads and mitigates the salinization of soil and aquifer, allowing the crops to develop better. That's an amazing result, isn't it? It surely is a starting point for new investigations and experiments on this phenomenon that is now increasingly global and relevant even in light of projected climate change. See you soon.
This is the video related to MOS project. Now we will have the other two, okay. Okay, first one is the video related to Change We Care. Hope it works. Probably we need some help from the regia. I'm not really... because we have already the most going on, probably. Se mi aiuti, grazie mille. Il primo, questo qua è il primo.
Plastica.
Sì, sì, sì.
Plastica. È ovunque.
No. Let's wait 1 second. Okay. So this is the one related, okay, to change we care.
The Adriatic Sea is the result of a long process which has given rise to the formation of sandy coastlines, islands, cliffs, river deltas, lakes, and lagoons. The principal factors that determine the morphology of the basin, as well as its chemical and physical characteristics, are currents, tides and winds, like the Sirocco, southeast wind, and the Bora, a northeast wind. The Adriatic Sea is a sea which hosts extraordinary biodiversity made up of fish, birds, maritime pine trees, mollusks, algae, and its coastlines are populated by human communities, with their fishermen, farmers, citizens, entrepreneurs, and tourists. But a threat looms over all of them: climate change. Change We Care was set up to face climate change. It is a cooperation project between the two countries which occupy most of the Adriatic coastline and which has identified how to face climate change by studying its effects, proposing solutions, and drawing up plans for the whole Adriatic area. How does climate change affect the Adriatic basin? The rise in global temperature causes changes in wind patterns and the dynamics of precipitation, fostering extreme events. Marine currents change. Their direction and intensity are influenced by the distribution of the water temperature, which is increasing. The weakening of the marine currents reduces not only the nutrients available for marine organisms, but also the oxygen dissolved in the water. The sea and its inhabitants are struggling to breathe, and the human communities find themselves facing sea level rise, storm surges, saltwater intrusion, alternate periods of flooding and drought, a drastic drop in fish resources. How can such a large, complex emergency be solved? By acting locally, making human communities more aware, responsible, and resilient. This is what the project Change We Care has done. It has identified 5 sites representative of the Adriatic coasts: Vron Lake, Neretva Delta, Jadro River with Castela Bay, Po Delta, and the Mula di Muggia sandbank. They are all facing common problems due to the climate change: saltwater intrusion, loss of biodiversity, loss of habitat, modification of sediment erosion, transport, and deposition processes, and specific problems such as periods of drought with low water levels, reduced fresh water supply, loss of farmland, conflicts due to the use of water for energy purposes, risk of flooding, reduction in drinking water availability, erosion of barrier island systems, reduction in aquaculture production due to rising sea levels and alien species invasion, conflicts between tourism and natural areas of protection, loss of landscape. These 5 pilot sites may be considered as an exportable model to face the challenge of climate change occurring on the Adriatic coastal strip. The aim is to make the whole area more resilient to climate change. But how to do it?
Asteris è un progetto focalizzato sugli acquiferi costieri. Gli acquiferi costieri sono un bene prezioso, ma come accade ai sistemi naturali hanno una vulnerabilità e pertanto questa vulnerabilità va valutata attentamente ed è questo lo scopo del progetto, che tiene in considerazione 2 elementi di rischio per questi sistemi. Da un lato il consumo di acqua che tende a togliere pressione negli acquiferi costieri, dall'altro la risalita del livello del mare, per cui un elemento legato a quelli che sono gli effetti e quindi gli impatti anche attesi del cambiamento climatico globale sui sistemi naturali e sui sistemi anche costruiti dall'uomo. Questo è lo scopo principale, essenzialmente quello di verificare e definire i profili di vulnerabilità e rischio per gli acquiferi costieri nell'area adriatica centro-settentrionale. Lo scopo è quello di appunto vedere la vulnerabilità, ma a diverse scale, da un punto di vista generale per quello che riguarda appunto l'area centro-settentrionale dell'Adriatico, e però anche avendo cura di andare a studiare 3 casi studio in particolare che devono servire come riscontro per verificare in modo più puntuale e dettagliato quello che è il modello di vulnerabilità. Le 3 aree sono l'area della municipalità di Fano, quella di Ravenna, che sono naturalmente sul versante italiano, e quello della valle della Neretva in Croazia. Queste aree sono state scelte non solo per la loro importanza turistica, economica, agricola e quello che è, ma perché rappresentano 3 casi studio diversi che poi potranno eventualmente essere esportati a situazioni simili nell'area considerata e oltre. Il punto è fornire ai decisori politici e a chi fa le politiche di gestione territoriale degli elementi per una più corretta gestione e sostenibile gestione territoriale, in questo caso appunto per quello che riguarda le risorse idriche sui sistemi costieri. Questo è un fatto molto importante, appunto gli acquiferi costieri sono un bene rilevante per l'agricoltura, per il turismo, per l'industria, diciamo. Lo scopo essenziale è quello di indicare appunto attraverso l'identificazione dei profili di vulnerabilità e gli eventuali modi di ricucire un po' la distanza con un rischio reale di esposizione all'inversione salina, quelle che sono le politiche di gestione per appunto i gestori territoriali. Il progetto si cala all'interno dell'ombrello di programma Interreg Italia-Croazia con una duplice funzione. Dall'altro c'è l'idea di un confronto scientifico fra partners che appunto sono di due paesi diversi, dall'altra appunto fornendo strumenti e soluzioni per la gestione territoriale. È auspicabile che queste si innestino in un confronto anche a livello di normativa che renda poi le azioni di gestione territoriale sostenibili su entrambe le sponde dell'Adriatico, ma anche con soluzioni, le migliori soluzioni in comune ed eventualmente anche con una base di confronto per quello che è la normativa e la giurisprudenza della gestione territoriale, che dovrebbe essere probabilmente la più comune possibile. Cioè l'idea è quella di trovare anche un solido terreno di confronto e di sovrapposizione per quelle che sono problematiche simili sulle due sponde dell'Adriatico. Questo senz'altro. Il progetto è in una fase cruciale perché tutte le azioni che dovevano essere fatte per la caratterizzazione, quindi diciamo le azioni a carattere scientifico per la caratterizzazione degli acquiferi sono state di fatto già svolte. In una fase cruciale, dicevo, perché adesso questo va tradotto e riversato dentro un contesto invece di linee guida per i gestori territoriali, che di fatto poi è lo scopo ultimo del progetto. Asteris vede la partecipazione di 7 partners, 4 di sponda italiana e 3 di sponda croata, e oltre a Urbino, che è il coordinatore, ci sono per quello che riguarda l'Italia il CNR con il suo istituto di geoscienze di Pisa, le 2 municipalità, Fano e Ravenna, e sul lato croato invece abbiamo Metris, Croatian Waters e l'Institute for Forecast and Crop Reclamation croato. Questa compagine assicura da un lato diciamo il contributo scientifico necessario a portare avanti questo lavoro e dall'altro appunto la presenza di municipalità e di gestori territoriali, che è esattamente l'integrazione centrale del progetto. Sì, l'Università di Urbino ha avuto il duplice ruolo appunto di coordinatore da un lato e dall'altro appunto anche di un apporto, ha portato degli studi a carattere scientifico, in particolare su questo la valutazione degli scenari di variazione del livello del mare, e in collaborazione con il CNR degli scenari climatici futuri, mettendo assieme questi elementi per la produzione di mappe della vulnerabilità e del rischio a livello generale, alla scala regionale, per gli acquiferi costieri sull'Adriatico centro-settentrionale.
Okay, so we have now an idea of what the 3 projects, Standard Plus project, are dealing with. And now we move to probably, I think, the most important, interesting part, at least in terms of scientific aspects of this afternoon, because we have let's say, involved 4 colleagues, and that are also friends, that will give us the possibility to understand. Of course, we know saltwater or soil salinization does not happen only along the Adriatic coast, but it is a problem, a worldwide problem. And so we will see what happens, which are the research and which are the, let's say, the problems that are affecting different other parts of the world. So the first one is Elia Scudiero is really. Ciao Elia, can you hear us?
Yes, I can, loud and clear, thank you.
Okay, nice to see you. So Elia was a former PhD student of Francesco and me. So we are, but he moved to California 10 years ago, more or less. I don't know how long, but more or less 10 years. And since then, he is working on salt water, on soil salinization in the California. And so he will provide specific talks on this aspect. Thanks, Elia. The word is to you, up to you.
Thank you very much, Pietro. It's a great pleasure to be here with you all.
So only a second, because the audio is not really. Can you ask Valentina just to raise a bit your audio?
Okay, no, I can get close to my microphone as well. Is that better?
Try, please.
Is that better?
Yes.
Okay, great. Well, thanks for having me. It's great to be here in close to sunrise here in California, and to talk to you about some of the research that we are doing here in Riverside, California, about near-ground and remote sensing of soil salinity on the agricultural land of California. So, as Pietro mentioned, I'm a faculty at the University of California, Riverside, but I have also joint affiliation with the USDA, US Salinity Laboratory that is also here in Riverside. So when we talk about soil salinity, we refer to the presence of the major soluble ions in agricultural soils. And we measure it here in California and mostly across North America as the electrical conductivity of a saturated soil extract. So we bring a soil in the lab and we saturate it with the eye water, and then we extract that solution, and then we measure the electrical conductivity of the solution, which allow us to classify soils from non-salt affected to extremely salt affected. And this is particularly important for agriculture because most of the commercial crops do not grow on extremely salt-affected soils. So it is of interest of the farmers to maintain salinity at a lower level so that they can keep their soil productive. Globally, salinity is a problem that affects around 1 billion hectares of land. But what is important is that 20% of the irrigated farmland, which produces half of the food that we consume globally, is affected by salinity. And 50% of this irrigated farmland that is affected by salinity is found in 4 countries: China, India, Pakistan, and then the US. So in the US, this is mostly a problem in the west side of the country, from the Colorado River Basin to the western states. We have areas with saltwater intrusion, but a lot of the salinity is found inland as well. The repositories of soil salinity in terms of spatial accounting are fairly coarse historically. So higher resolution repositories are needed to enable site-specific management or better management of the field scale on how to control salinity. So when we look at salinity at the field scale, we can notice that there's often a lot of spatial variability, which is influenced by multiple factors, such as the texture at the site for the soil type itself, the irrigation management, and these results indeed in high short-scale spatial variability of salinity. So when you go in a field out here, you will see sometimes that you will notice that there are salt at the surface level of the soil, but most of the salt in irrigated farmland is found below the soil surface, which is a problem for assessment because it is very hard to understand how much salinity is in the soil profile, which is what really affects the crop growth. So to overcome this challenge, we use a combination of traditional soil sampling and high-resolution geophysical measurements to map and monitor field-scale soil salinity. So the main field-scale technology that we use is the soil apparent electrical conductivity, which can be measured through resistivity sensors or electromagnetic induction. Electromagnetic induction, or EMI, is what we focus mostly in my lab. And these type of sensors allow us to measure soil properties with different depths of penetration. So 30 centimeters, 75 centimeters, a meter and a half, and so. Although this is a complex measurement, so there's not a direct measurement of soil salinity because it relates to how much electricity can be conducted by the soil. And this depends on the pathways that the electricity can have through the solid particles in the soil, the liquid phase of the soil, and the interaction between liquid and solid phases. So whenever you have a measurement in the field with the apparent electrical conductivity, it will depend on several soil properties. If you have high salinity, you would have high apparent electrical conductivity. The same goes for water content, clay content, whereas anything that can resist the electrical conduction in the soil will result in lower readings. So one thing to say then is that when you have flood irrigation or sprinkler irrigation, you will have like a very homogeneous in horizontally homogeneous layer. So we generally do these soil measurements with the apparent electrical conductivity after an irrigation, so that we are close to field capacity, and we maximize the liquid pathway in the soil so that we can have good readings. So the way we do it is that we utilize the protocols developed by Dennis Corwin and other colleagues here at the US Salinity Lab, which go as follow. First, we do a sensor survey for the field, collecting thousands of measurements across a field. Then we use statistical methods to delineate a representative sampling scheme. Then we go and sample those locations, and we bring the soils to the lab. And then, because this is not a direct measurement of soil salinity, we develop site-specific calibrations. Generally speaking, the easier way to go about this is to use a regression modeling, and that allows us to create maps of soil salinity or other target soil properties across the entire field. Although, because nowadays, thanks to the fact that a lot of people are using the same protocols across the US Southwest, we have access to this type of data from ECA sensors and soil direct measurements of soil salinity from lab analysis. We can develop models that are based on machine learning and leverage the knowledge from these hundreds of surveys that were done in the past. And that's the work that one of my postdocs is doing, as a matter of fact. So whenever a new survey is done, it's added to a historic data set, and then the data set is harmonized and so on. And then the best model to predict salinity at the field scale is developed. And this is then used by modelers to develop regional scale hydrologic models, or to map salinity at the field scale and then manage field scale soil salinity. So I briefly mentioned now the regional scale, and obviously you cannot go in millions of fields and do soil surveys like the one I just described for every single field. And also, it's very hard to extrapolate the knowledge that you gain for one field to the field next to it, because sometimes, due to different management, such as the access to different water sources, neighboring fields have totally different outcomes in terms of salinity. So here we have two pistachio fields that were planted around the same time, so they are equally as old, same varieties on the same soil series. Farmer over here has only access to groundwater that has a high salinity, whereas the farmer down here has access to surface water, which is no melt from the Sierra Nevadas, and it's a much lower salinity. And you can see after years of irrigation with different waters what the difference is even visually. But there's one opportunity here, because remote sensing can capture these differences from field to field. So if we find a way to gather the information from the field scale surveys and then match them with remote sensing, then we can perhaps map salinity across very broad areas. And we do this using reflectance products from different satellite sensors. Especially we focus on the visible and near infrared bands. And we developed an index that works similar to NDVI or EVI or other vegetation indices that you've made aware before. And as well as other indices, these are not direct measurements of soil salinity, but rather indicators of relative crop status, such as stress versus non-stress crop, but also the crop type, the phenological state of that crop, and the soil type that is under that crop layer. As I know here, of course, thermal imagery can be used with the same approaches. So as I said before, this is not direct indicator of soil salinity, so we need to match it with some modeling to the ground measurements that we take. And the way that we do this is by doing multi-year time series of analysis of this remote sensing imagery. Because under similar management, the salinity stress is fairly permanent, so it can be regarded as a constant in the root zone for a limited amount of years, of course. So plant performance measured with these vegetation indices is maximum when all the other stressors are at minimum. So no water stress, no other, say, pests, or no mismanagement of irrigation and such. So salinity then is the only limiting factor for the crop. And so if you take this multi-year peak performance of the growth, that is then it becomes related to salinity stress. So again, for every single pixel in the region or every single location, you look at the maximum performance, and here is the green is the plant performance, and compared to the relative maximum that crop could have, the limitation is only due to salinity. So then we developed and further tested this method using fields from the Central Valley, which is one of the most productive areas for agriculture production globally, I would say. And the western side of the Central Valley is affected by soil salinity. So we have 22 fields there that we sampled in 2013. This is like the pilot study that we had for when we developed this method from remote sensing that we've expanded through the years. But that study comprised 22 fields, and we had quite a few electrical conductivity measurements and 267 soil samples, and we focused on the average salinity for the 0 to 1.2 meters. And again, we go out in the field, we take the sensor measurements, then we identify the representative locations for sampling. We develop models that can relate the sensor to the actual salinity that we want to map, and then we aggregate this prediction to the resolution of the satellite product that we are using for mapping. So this multi-year maximum outperforms any other method that we tested or that the literature presented before. But it's not the silver bullet for mapping salinity, because still the relationships are quite low between salinity and this remote sensing. So by adding information about the crop type, the climate, the soil information and management, we are able to increase the goodness of fit of these prediction models for quite a bit. But this is not the end of the work, because this has been totally validated and evaluated by third parties and independent studies. And then only once you go through these evaluations and then you go to the farmers and compare the data that they have with the data that you're showing them in the new map, then you can be confident that you are representing actually the process that you're trying to map. And here's the pilot studies outcome that we had. That was the map for the western side of the San Joaquin Valley. Nowadays, we are developing maps for the entire U.S. Southwest and focusing also on the time series from the early 80s to current time. So how do natural resource managers use the salinity maps that we produce? So there's some people on Stanford University that are trying to account for the economic impact of salinity in the agricultural production. So they do econometric studies based on soil maps, and they include our soil maps on this. And there are other people that are including the salinity for improving the leaching recommendations to the growers at the field scale. So how much excess water you need to apply to push salts beyond the active root zone for the plants. So I think this is all I have for you today. It was a pleasure to highlight the research that we're doing here in Riverside, California. If you want to reach out to me, here's my contacts and the links to the lab and some of the publications that we published on these regional scale models to map soil salinity. And of course, do not hesitate to contact me if you want more details, because this was rather fast. Thank you so much.
Thank you, Elia. Thank you a lot, Elia. Okay, so I think we can go on. Okay, relatively quick. Thanks. So have a good day, because for you it's early morning. So
thank you so much. Yes.
Yeah. Okay.
Bye-bye.
Bye. So we move to the second one, and this is here with us. He's Francisco Serdone from the University of La Plata. Okay, he's staying here for a few months, working at the CNR and also with us. So, Francisco, it's up.
Bene, buongiorno a tutti. Good afternoon to everyone. Thank you very much for the invitation. Well, here I'm presenting yes, I have to full size the presentation. Let's see how it's better. See here, no, I prefer this size. Sorry. Well, the title of this presentation is the role of the hydrostatic graphical setting in controlling freshwater saltwater interface in the Rio de la Plata coastal plain in Argentina. I'm Francisco Aldo Celone, Pietro told you, from the National University of La Plata and the National Scientific and Technical Research Council in Argentina. And the location of the study site is in Argentina, particularly in the province of Buenos Aires, in the southern margin of the Rio de la Plata estuary. Here is the Rio de la Plata estuary. The littoral zone of the province of Buenos Aires and the Rio de la Plata is characterized by extensive and low-lying coastal plains, which have an extension of approximately 400 kilometers. And these coastal plains were formed during the sea level fluctuations during the post-last glacial maximum. To characterize the estuary, we have to say that it has a mixed semi-diurnal microtidal regime, characterized by a mean range of 0.7 meters, and the salinity ranges from 0.5 grams liter in the upper estuary here. You can see here or no? Sorry. Okay, thank you. Here in the upper estuary, 220 grams liter in the lower estuary. We selected 4 different zones from 1 to 4 in different regions of the estuary. So one is placed in the middle estuary, the same in zone 2, and the upper estuary and the adjacent marine area. We choose this zone 3, and zone 4 is in the adjacent marine area. Well, these sea level fluctuations during the Holocene gave rise to the deposition of different sedimentary phases. Here we have the tidal floods environments. Here the old tidal floods environments currently disconnected from the estuary, and here the present tidal floods. Here we have Shelly Beach deposits, Shelly Beach ridges deposits. Here next to the sea we have Sandy Beach ridges. This is coastal dune systems, and we have also the coastal plains, Aeolian sand sheets that were formed by the dunes systems. And here, in this zone, we have a Loessic Pleistocene plain. In this region, the freshwater supply for human consumption is one of the main problems for the socioeconomic development, being the freshwater lenses the primary or the only source. These freshwater lenses are mainly stored in the permeable units such as the beach ridges, the sand spits, and the coastal dunes, but their shape and distribution and the saltwater and freshwater interfaces are still not well known. These are satellite images of the different zones. Here you can see in zone 1 the disposition of the shelly beach ridges parallel to the coast, the present marsh, and the tidal flat that lies 6 meters above the present sea level and is currently disconnected from the estuary. In zone 2, we have almost the same situation with the marsh here, the shelly beach ridges, and the tidal flat. Zone 3 is characterized by tidal flats environment, which are currently connected with the estuary, beach ridges, and a spit. This spit has immigrated, progradated towards the north sector, the coastal dune systems, and tidal flats that are currently disconnected from the estuary. Zone 4 has almost the same landforms that in zone 3, but we have some sand sheets above the beach ridge deposits. These are photographs of how you can see these different landforms in the field. This, for example, is the tidal flat that is currently disconnected from the estuary. This is the tidal plain and the channels. This is spring water. The ridges, the shelly beach ridges, the spaces between them, marsh environments, and I think it's not working anymore. And I don't know what happened. It stopped working.
Yeah. we can riavvia il programma. Let's do like this.
Next. Here we are. The marsh environments, I don't know why it's not working, and old dune systems.
No.
It's not working. Here. Well, regarding the evolution of the Argentinian littoral of the Rio La Plata estuary and the Adriatic Sea area, it began about 125,000 years before present in the Pleistocene, where the sea level was above 11 meters above the present sea level. In that time, these beach ridges systems were formed. Then it continued 5,000 years before present with the second transgression during the Holocene, where it was formed this tidal flat environment, and the speed here started prograding towards the north. Then, 3,000 years before present, the speed continued migrating toward the north. The shell-rich systems were formed, and in the present we have this situation, this scenario, with the coastal dune systems and the marsh environments adjacent to the present coast. This is a channel in the middle estuary, which outcrops the shell-rich ridges. So you may note that they are above the present sea level. These are mills for pumping water from the aquifer and the freshwater lenses that are stored here. Well, the aim of this study was to analyze the role of this hydrostratigraphic and geomorphological setting related to the Holocene evolution of the Rio La Plata estuary regarding its control on the freshwater-saltwater interface and the shape and distribution of these freshwater lenses used for water supply. The methodology was very simple. First, we performed a geomorphological characterization using satellite imagery complemented with high-resolution Tandem X digital surface model. Then we installed groundwater exploration wells and did sediment samplings in transects that were crossing the coastal plain. Also, we analyzed cutting data from drillings deeper than 12 meters, and we analyzed previous geological profiles. Electrical conductivity of the water was measured in situ in wells and piezometers, and we performed also 21 vertical electrical soundings. Here is the situation for the Zone 1 where the sand and shell-rich ridges lie above the silt deposit, the Pleistocene silty deposits. These silt deposits correspond to the Holocene plain that outcrops in the continental area. And as you can see here, the freshwater lenses are associated with the beach ridge deposits, with the main freshwater reserves stored in these underlying Pleistocene sediments. In this sector also, the freshwater and saltwater interface is related to a paleo-saltwater intrusion related to the Pleistocene and the Holocene transgressions, as you can see in this scheme. And this is the shape and distribution of the freshwater lens stored below the beach ridge deposits. In Zone 2, beach ridge deposits lie above a silty, a clay layer close to 2 meters thick, which is strongly bioturbated. This clay layer corresponds to an ancient coastal plain and has several interconnected tools filled with sandy material. Below these deposits, also there is a layer of silty deposits, loessic deposits. In this zone, like in Zone 1, the freshwater lenses are associated with these ridges, and bioturbation in this clay layer allows water infiltration. Locally, it decreased the permeability, so the thickness of the freshwater lens is less than in zone 1. This is an hypothetical scheme of what it should be without bioturbation, the freshwater lens is what should be. And this is the actual shape of the freshwater lens with this clay layer with bioturbation. In zone 3, it is dominated by sandy deposits of big ridges associated with the migration of speed here and here. And dune systems are formed on top of these beach ridges and aeolian sand sheets. In zone 4, aeolian sand sheets are located to the west of the beach ridges. These aeolian sand sheets are deposited above a thin layer of sand here, developing both sandy deposits close to 3 meters thick. Below them, there are clayey to silty sediments associated here with deposits from ancient coastal plains. So in zone 3 here and 4, the freshwater lenses are associated with the sandy beach ridges overlaid by sandy sheet and dune systems. Both the topography and the presence of low permeability phases are the factors that determine the thickness of the freshwater lenses. Even though the aeolian sand sheets and the beach ridges found in the more continental sectors accumulate rainwater in the shape of lenses, they are thin and therefore do not represent relevant water reserves. The thickness of the lenses is less than 2 meters, like here. In contrast, here, when the aeolian sand sheets and dunes develop on beach ridge deposits, freshwater lenses can develop reaching thickness of 20 meters on average. Well, just to conclude, the Holocene evolution of the Rio de la Plata estuary and the adjacent sea area gave rise to the position of beach ridges and spits associated with aeolian sand sheets and dunes. These deposits have higher altitudes than the contiguous tidal flats and are composed of highly permeable sediments, characteristics that favor rainwater infiltration and the development of freshwater lenses. The variability in the dimensions and thickness of the lenses and the position of the freshwater-saltwater interface were explained from detailed lithological studies that showed an interdigitation of ridge and spit deposits with clayey environments of tidal flats as a result of sea level oscillations during the Holocene. Different architectural arrangements determine the morphology and thickness of the freshwater lenses and the position of the freshwater-saltwater interface. Thank you very much.
Thank you. Thank you, Francisco. Thank you a lot. So we move to the next speaker, that it is remotely connected. It is Gu Essink from the Netherlands. Hi, Gu, nice to meet you.
Mm-hmm. Hi, nice to meet you. Nice topics I saw. Argentina, yeah, very interesting. Hi.
Okay, so Gu will speak about
some kind of a delay, yeah?
Yeah. But now I'll give you the word to you. So just a quick introduction. So he will speak about the problem of saltwater intrusion in the Mekong Delta, that it is also really a big problem for this very low-lying area. So Gu, up to you. Thanks a lot for participating and giving your contribution to this event.
I think it's a very important topic. So I'm now in Gdansk, Poland. Can you see my first screen?
Yes, it works.
Okay, so I remember there's a delay of a few seconds. Okay, I will start my presentation. I do that on behalf of my co-colleagues, Hung Van Pham, Vice Director of an Institute in Vietnam, and Philip Minderhout, who's also worked a lot in the Mekong Delta. It is about fresh groundwater under stress, the Mekong Delta case. But I will talk about this specific case, but I have done, together with colleagues, many things also in the Netherlands. And when we consider both cases on one sheet of the Netherlands, I think also the things we have done in the Netherlands are quite interesting too. So what you can see here, some snapshots of colors of things we work on. We work on conceptualization of the fresh groundwater resources in the Netherlands. That's maybe the bottom left, how the subsurface looks like, where fresh water is, where salt water is, what is the reason why it's coming there. We worked on airborne survey. Of course, André will tell us something more about that, but we did it also in the coastal zone of the Netherlands with large-scale areas. We're now planning to do the whole of the Netherlands, the low-lying area of the Netherlands, do the airborne survey. We worked on modeling in 3D the coastal zone with parallel computing possibilities using supercomputers, because salt rod intrusion modeling is very slow and very tedious. It takes a lot of time, maybe days to weeks. So we have the parallel version to speed it up. We work, for instance, also on the projections of sea level rise on the volume of fresh water, which is used for drinking water. And also it's important topic for us is that when the surface water gets salinized, you need more flushing water. You need more fresh water to flush these ditches and these drains and channels. And if we check that out in the Netherlands case and we have a sea level rise, we see that the whole coastal zone, there will be not enough fresh water available to flush these coastal zone areas. So I think this is a very important freshwater availability topic in our delta, but I think also in other deltas. When I continue to the stresses in the Mekong case, this is a snapshot of pictures in the news and the media about serious droughts and serious salinization. It's an important area for the Mekong people and for Vietnam people because it's the rice bowl of Southeast Asia. 20 million people live there. And what I saw when I was there, I saw that if people don't have enough fresh water in the rice season, they have to stop doing their agricultural activities and they have to move on to the big city. So I really see that because of salinization, people are on the brink of moving to cities. So it's an internal migration issue over there. And as I showed you here, it also affects crop productivity. And we showcase our knowledge and our understanding of the system to the government over there and to the provinces. And they in the beginning didn't see the connection between climate change, sea level rise, extractions, and now they are seeing it, and now they start to change their attitude. So it took maybe 5 years, but you see now they suddenly see that if you extract too much water, I'll come to that later, then you will cause trouble, and then irreversible trouble, and maybe in the future will be no Mekong Delta anymore. So what we worked on that is for the Mekong case. Maybe some of you have seen this picture already, but that is not only specifically for the Mekong. It's also happening around the world, and we also are checking out the deltas around the world. And this is just a case. So basically, before humans came there, it was a natural swampy area. We saw that also in the Netherlands with mangroves and relatively high-lying area. There was not so much happening. And then over time, you will see, if it works well, you see that people start to use the land. They created agricultural areas, and over time you see population did grow, and the fresh water from the river gets contaminated. The quality gets less good, and as a function of that, they want to create extraction wells. They did that a lot in the Mekong Delta. Not so many years ago, 25 years ago, 30 years ago, they suddenly started up extracting a lot of water out of the subsurface. And by doing so, more things happen there. They need more water. There are created dams in the coastal zone, but high inland, maybe in China. They had to reduce discharge and sediment supply. So also more to the coastal zone, in combination with climate change, there will be flooding because there's less sediment to protect. And because they start extracting sand and water, they will have flooding, salinization, coastal flooding from the sea directly, contaminating the coastal zone, and also they had erosion because there was not enough sediment. So it's a combination of sand, and it is a combination with groundwater, sand and water, groundwater extraction. It's all connected in this case, and that is interesting. What is also important to know that if you continue to extract, that's the topic of today for me now, is you have more salt water intrusion in the bottom right. And because of that, if you do extract too much, you have upconing of salt. And we definitely see that in measurements, in data from the Mekong Delta. And I will tell a bit more about this topic. What is also important, of course, there's a sea level rise, but as you of course also know, Professor Pietro, that there's also land subsidence, and that was happening over there in the Mekong Delta. I come to that later, a short moment, but they extracted too much water, they have salinization, and they have subsidence. And the subsidence part can be larger than the sea level rise. Maybe it's up to 100 millimeter in certain deltas, not in the Mekong, but a bit less. But the sea level rise is less. So if people are worrying about sea level rise, they should also worry about a bigger problem for the delta. And that perception is now told to them, and they start to change their attitude. I think that it's important. It's subsiding because it's important. There's a clay layer on top of many deltas. So if there's clay layer on top of many deltas, the precipitation in the wet season cannot happen. And then you will see the water doesn't go into the subsurface, it goes directly to the sea. And then extraction really matters. If I continue with that, the relative sea level rise, we checked out many deltaic areas around the world. We checked in project through Deltares. I am from Deltares and an associate professor from the Utrecht University. What we see is from a freshwater groundwater point of view, many deltas are under stress, and there are basically a few stress factors, and I named them here. That's of course extraction, over-exploitation of groundwater. An important combination is that if there's a limiting refreshment because of the sealing of the clay layers, they do not permit water to go in the deeper area, in the deeper groundwater system. This extraction and the sealing that combined causes land subsidence and salinization, because somewhere the water must come from, and that should then come from deeper groundwater, and that is often saline. And of course, for the future, we have sea level rise. That is sea level rise pushing salt water more inland, but in many areas where there's no protection from flooding, then there's also the fourth point here, an overwash of saline water during storm surges and floods. And this water, as you can see here in this picture in the left bottom place, this overtopping, this flooding event happened also in the very long past, in the past, that's thousands of years ago. But that also the salt water is heavier. And as it's heavier, it can easily infiltrate in freshwater resources. So I think this overwash concept is often forgotten. And I think it's in many deltas without serious protection is one of the major reasons that salinization will be a big issue, I think. Now, continuing back to the Mekong case, we can say these projections and ideas because we founded our ideas, our knowledge on two things. Of course, a lot of data. That's data coming from all those partners you see below. Partners from Vietnam, partners from sometimes from the Netherlands. We did some airborne survey over there. Small one, we did a walk time data analysis over there. So we collected those data and we brought all that data together to estimate, for instance, land subsidence. You see this picture on the left. We also estimated groundwater salinization, that's still ongoing work. And also we did some surface water salinization modeling. And that was basically only work from 3 PhDs. Of course, it's not only, it is very important work. It was funded by the Dutch government, only €1 million, which sounds a lot, but they now have the tools to project the future, and they can use these tools to also analyze possible mitigation strategies. I come to that later. Now, one other thing we worked on, they had no idea how much water is there in the subsurface. They had a lot of data. It's amazing how much data they have. They are a communistic state, and all the data is collected in a central place, and we are fortunately to have that data. Though it's important. Some deltas don't have that data, others have. For instance, the Nile Delta doesn't have a collection of the data in the database, so there very limited amount of information is there, but we were fortunate in the case of the Mekong Delta. And what you see here, we combined all those different kinds of data as points from samples, from bore logs, and also from pumping wells. And if you combine that all together, we could have had estimated the total volume of freshwater in the whole of the Mekong. That's about 830 to 900 billion cubic meter, basically. Kilometer to 3 billion cubic meter. And we could also determine that per province and also about depth. And you can see here just some details. Per province, we can determine how deep that water is. That is often in a certain deep aquifer, which is more than 200-300 meters deep. And sometimes areas, there's no fresh water at all. And what is interesting, for instance, and in this area, the Kamau area, is very low-lying and it's completely surrounded by the sea. And you think then there will be no fresh water. But if you check out here the Kamau Delta, here, I hope you can see my mouse. But here in the third row, the bottom, Kamau, you see in the deeper parts, there's a lot of fresh water. That is an amazing amount of fresh water. And that's not implemented there at this moment. It was implemented in the far past. I come to that later. We use this knowledge to see what is fresh and salt. So you can see an animation, and when it is green, you see it is too salty to drink. It's too salty for crops, and it's important for them to know where is there fresh, where there's salt, how much can I extract. And this knowledge will be used in numerical models to estimate how much you can extract in a sustainable way, not only for salinization, but also for land subsidence. Now, you think now that 900 billion cube, that is the number I show here, 900 billion cube, or maybe 830, depends on the uncertainty was there. But that sounds a lot because they only extract 1 billion cube per year. So there is 900 and you only extract 1. And you think, now, that is not the problem. And this is my intermezzo I always like to show, is that the volume of fresh water and the stresses. And I have two cases. Let's first start taking the right case of the Mekong Delta. So there is, let's say, 860 billion cubic meter water. It's a lot, and you only extract 1. And the recharge, the precipitation, is 45, meaning that when you only take a small number out, what is the problem then? You think there's a lot of precipitation, 45 times more, there's a lot of volume already there, so why there is a problem? And there is a problem because land subsiding is there over 25 years. There is also a lot of salinization, and that is because there's a clay layer on top of the system. This water of precipitation will not infiltrate. And if you extract in a certain local place, in that local setting, the salt water can go up. So you combine different kinds of numbers, you think you are safe and you're not. It's the same like in the Netherlands. We have 1,100 billion cubic meter water. We have a precipitation over the winter and the season. We have precipitation of 30 and we extract 1.5, and we think, what is the problem? It's only a small amount, and yet 20% of all drinking wells have been abandoned. They are too salty. So that's important message, I would say. You think you have a lot. It's not, because precipitation is much less really in the deeper part, and it is a local process. And if you extract, you can have really salt water from very big depth. Now, what I don't know how much time I have. I have a few sheets on the reconstruction, but I think the past is very important. It's up to you to say how much time I have, but then if I don't hear something, I continue. We think that understanding how it is fresh or salt in the deeper part of the Mekong, it's caused by the very far past. And that is a reconstruction of salinity in the Mekong Delta in a two-dimensional profile. And the reality is, of course, much more complex than 3D. We think that with this concept we worked out in an article, we can at least showcase that the past matters in this specific case, and I think also in cases in Italy and in Croatia, I would say. So these, on the left side, we have measurements of salinity in the deeper part of the subsurface, and on the right side we have age data of these wells. As I said, they have a lot of data. And what we did then, we modeled the salinity over 40,000 years. And it's basically, on the right side, you see a model, and we start with completely salt water, and we have all those monitoring wells, and then we start this simulation. And what we have here is that the sea level was very low in the very far past. We put here a lot of geology, complex geology in, that's shown in the article. And if you start this model, you see that salt water infiltrates because it is fresh water infiltrates because it's fresh and it pushes away the salt. You see here that the sea level goes down. So also offshore, this is the coastline, by the way, also offshore, it gets completely fresh. But over time, the sea level goes up again over 40,000 years. And you can see it here. And over time, you see the time of 30,000 years, salt water even overtopped, overwashed the whole area. And this is basically after 40,000 years, this is the present situation. What you see, if you see the measurement, sometimes it is fresh, sometimes it's brackish. You can find very fresh water, very deep at 500 meters. Sometimes you can find it very shallow, it's brackish. And we think that this transgression and regression of the system, infiltrating clay layer on top, this combination of geology and sea level transgression and regression gives us a knowledge about where salt is coming from in the Mekong Delta. Yes, and we did not only do that with salinity comparison, but also with age comparison. And we think this heterogeneity, even only 2 dimensions, can be reproduced. So we think that most of the fresh groundwater, and that's an important message, most of fresh groundwater in the Mekong Delta was recharged between 60 and 12,000 years ago. That means that the water you extract now is water which is old water from the past. And we see that at present, the hardly fresh water of groundwater is being recharged to the high resistance of the top layer of the clay layer, which I already explained a few times. So what we see here in the Mekong Delta, if you extract water, you have upconing, and that is local project, so local phenomena. So you think it is safe, then maybe the interface before extracting is maybe 50 meters lower, but you can contaminate the whole system within 20 years, 5 years, 10 years, depending on extraction. And it's caused by natural salt water intrusion and by mixing with fresh water. If you extract a lot of water, large velocities, you have mixing. And that makes that fresh water will vanish, will become brackish water, and you don't have fresh water anymore. So you have to watch out. You have to know where you could extract given a certain volume. And the rule of thumb is for every 1 cube water you extract, you lose about 10 of the fresh water stock, because that fresh water is mixed with brackish water. So you lose that. So watch out for extraction. Nearly there. As a solution, we think that instead of extracting only fresh water, for instance, for aquaculture, mix it with brackish water, give it for the shrimp farming cases like here, the present situation. You have subsidence, but also you have mixing, as I said, and that is not a sustainable solution, because this water was infiltrated many thousands of years ago. So it would be much better, and that's the idea, that instead of extracting fresh water, maybe start extracting brackish water, desalinize it, and combine it maybe with water quality good enough for shrimp farming. So we have to rethink about using fresh water in the Mekong Delta. It also mitigates groundwater extraction, because you will at least fresh groundwater extraction. And if you do it in a smart way, it also reduces land subsidence. And also, if you also in combination create freshwater volumes, you infiltrate water in aqua storage and recovery setting. So the wet season is very wet and the water goes to the sea, but why not take that water and infiltrate it? That would be much smarter. And that kind of concept we try to implement in certain projects in the Mekong Delta, but also, by the way, in the Nile Delta. Now, 2 sheets, it's not only aqua storage and recovery, I think you need a combination of smart freshwater practices. I see in many deltas, there's no solution that fits all. You must combine things. The first topic here, try to regulate and minimize extractions. The second one is water saving in agriculture, drinking water sector, and industry. I think maybe in certain places where you see it is prone to sea level rise, think differently. Do not use fresh water, but maybe relieve the fresh water demand, go to salt-resistant aquaculture, or reallocate crops. I think, as I said, number 4, as I showcased you in the last picture, is aqua storage and recovery. Try to store the water when you have a lot of fresh water in the winter season and store it in the sun, and extract it for the dry season. I think you should start to increase rainwater infiltration in coastal zones. So stop sealing, stop making concrete areas, try to create more seal infiltration areas. I think we should also go to wastewater in a circular economy. And my newest possibility, I would say, is that focus on brackish water and desalinize it. A certain kind of brackish water is good enough for many many crops, many industrial activities, and you should rethink your use of fresh water and start to think about brackish water. I think I leave it like this. No, these are the points more or less. So the point is that on the long run, delta life is not obvious anymore. If you start extracting more and more, it will be so low that with sea level rise, it will be overtopped and it will subside below sea level and you are in serious trouble. I think point number 3, it's not a free resource. If you extract, you pay with elevation, subsidence, and sanitization. So you should maybe tax it better and more than we do now. And I think before implementing measures, you should first understand the system better, how it works, how it flows, how it goes. And I see that using models is very useful to persuade policymakers and also evaluate stresses, projections, and come up with effective measures. And as I said, no solution fits all. I think it's a combination of tailor-made strategies to come to adaptive pathway settings to a sustainable freshwater supply system. With that, I leave you. As I said, the last part, create a sense of urgency under water management policymakers and investors also. If the investors see that there will be no fresh water in the future, before it really happens, they will already stop investing. So they can be maybe 10 or 20 years earlier. So notice that, that's a very important topic, which is not taken into account enough, I would say. That's it.
Thank you, Gu. Yeah. Really nice and really interesting presentation. So really thank you a lot for contributing to these days. And let's say it's a pleasure. So let's hope to meet in person next time, right?
Yeah.
Okay.
Ciao, ciao.
Ciao,
okay.
Thanks. So we move to the last talk given by Antonio Menghini. So if you look in the, let's say, in the time schedule, we have Andrea Viezzoli, but Andrea does not have the possibility to come here. So Antonio they work together, so he can for sure, let's say, explain. Perfectly. Okay.
Thank you, Pietro. Good afternoon. Don't worry, I will speak English more slowly than the Dutch guy. So I'm pretty sure it will be. But anyway, I'll try to be very concise.
I will send the PowerPoint later, right? I will send the PowerPoint later.
Anyway, I work for Aarhus Geophysics, which is a Danish company based in Aarhus. But we have also an office in Italy, in Pisa. The Italian company is named Emergo. Both of the company are specialized in the processing of airborne electromagnetic data that are used, for example, by Delta Res in Vietnam and most of the Netherlands too. And certainly, can I start? Okay. Certainly the airborne EM is a very useful tool for hydrogeologists. First of all, because it's able to cover very large areas at the size of a basin scale. Secondly, we can achieve a great data density. That means many resistivity modeling. That is much more than any ground-based geophysical method. Third advantage is the good penetration. It is not really updated because right now we can reach a depth of about 500 meters and more. It depends on the resistivity of the subsurface, of course. It's very fast, and it is very important because if you need to assess a snapshot of the situation, you can cover in one day 300 linear kilometers. So you can map very fast coastal area. And in theory, if you have budget, you can repeat the same survey in a different season or in different years. So the methodology is very useful for time-lapse estimation. It's cost effective because we have a range of 100, 200 euro per kilometer. And it produces quantitative result. It's not qualitative, so we can recover deterministic parameters, and the value for the management is very nice. Very quickly, how it works. We have a system on a helicopter. We have a transmitter that is the big loop that has a diameter of about 20 meters. And in this loop, we inject current. This current is a pulse current, so that we can produce a primary magnetic field that is the white field. The quick decay of this primary field induces eddy currents, the yellow one in the... Can you? No. But anyway, it does not matter. Okay. The eddy current is the yellow one that induces into the subsurface. And the very fast decay of these eddy currents produces a secondary magnetic field that is the black one, that is recorded by a receiver that is mounted in the same frame of the transmitter. So the system is compact, and it can fly very, very quickly. And the result is this transient, that is the voltage response, the decay, the Earth response, following our impulse. So the second step is to model this transient, so to recover conductivity or resistivity 1D model that can be georeferenced, so that to achieve a map of resistivity or conductivity at different depth or elevation. So we can achieve a 3D resistivity distribution. In order to get this outcome, it's important to have good data. So it's important to use a high performance system. Not all the system has the same quality. Then there is important to proceed with a good processing, very accurate, so to exclude any distortion due to infrastructure, because the presence of human man-made infrastructure is a limit. You need to fly far from any buildings, far from any cities, railways, power lines, and so on. So this is a limit of the system. But in spite of this, we have applied this system, this methodology in a very populated area in Italy, very recently in the area of Brescia, in Milan, but all over the world. We worked in Netherlands, Belgium, and so on. Then we need a good inversion, so to recover a good resistivity distribution. We can integrate these results with ancillary information coming from other geophysical methodology or from boreholes, from stratigraphic data. Finally, we can derive products that could be simply lithological voxel, lithological model, but also hydrogeological model or other derived products. So this is a very short video. I tried before, it worked, I don't know why. Now, forse, sì, ecco, vai. Okay. Are they okay? This is just, sorry for the bad music, but South African people is not so good. But anyway, this is the South African system. So you can see the loop is 20-meter diameter, and at the center of this loop you have the receiver. Okay. So the system is concentric and is able to cover very, very large area in very short time. So essentially we can sample data every 20 or 30 meters. So when you perform a survey, you this is the density along the flight line, okay? But according to the flight spacing, that is the distance between adjacent flying lines, you can decide how to be you need a grid resolution or not. I mean, if you are interested in hydrogeological application, is it important to keep a spacing of about 100 meters, not larger? In other cases, if you are interested to map a very large area, it has sense to start with a larger spacing, 1 kilometer, and then to go to an infill, so to inspect the first preliminary data and decide where to infill by using a denser spacing. Let's go to some example of application. This is a case study in Australia. We worked for the DOW, Department of Water. And we are in south of Perth, and this is a map of conductivity at the different elevation above sea level. So the colors in this case define the conductivity, and you can see that going deeper we have a clear encroachment of the seawater into inland. And just to the right side you can see some blue, some less conductive layers that are limestones or sands. These are two sections that we can see now, and we can compare our 1D modeling of conductivity with the geological cross-section and hydrochemical cross-section. Let me start from the latter one. In this case, we have a very good agreement between the high content of salt due to the seawater interface, and also due to this lagoon with this high conductivity. So that it's impressive to note also the same dip of the interface. So the system is the method is very accurate. The blue, the less conductive layer, are limestones that and the sands that recharge this aquifer. Then we have also this shale that has an intermediate conductivity. So if you compare this expected geology, this is provided by the OW before the survey. So it is not based on our result. So the agreement is very, very fine. This is another section. We overlapped this high salinity zone with this high conductivity. Also in this case we have a very good agreement, and maybe you can follow this ISO. I don't know in English, isoaline. Well, I don't know. Anyway, with this conductivity contrast, it's very, very, very fine. This is another example from Belgium. And in this case, this is a map of depth of interface. In this case, it is not resistivity in this map, while this cross-section shows the resistivity distribution, in this case low resistivity red, and with boreals and other information. So you can see very, very clearly the deep inland of the interface of the seawater and the fresh water. But let me go to this other map in detail. So we have the depth of the interface. In this case, the Belgium hydrogeologist suggested to use the 6 meter surface in order to detect the fresh saltwater interface. So we have this situation. Of course, the red in this case means very shallow interface. So this is a clear encroachment of the sea, while in this case we have a better situation. This is a section showing the salinity, TDS salinity from different boreals, and the color denotes the lower and the highest salinity, and the depth of the sampling. If we overlap the interface derived from the airborne EM, we can have a good agreement between the lowest salinity and these that are above the interface, of course. I lost the... Okay. That are above the interface, while in this case we are below the interface with very high conductivity and salinity. This is another overlap between the depth of the interface and the salinity measured all over the channel. So you can see the legend of the salinity of the channel is this one that has a similar color code of the map, and there is a very good agreement between the highest value with the shallower position of the interface and the more salted channel. This is a bad case. This is a case on the contrary in which we have a good agreement between low salinity in the channel and deeper interface. This is an example of time-lapse monitoring. In this case, they exploited an old VES campaign, vertical electrical soundings, performed 40 years ago. They used the same 6 meter surface, and they compared these 6 meter coming from the old survey with the new airborne EM, so that you have this map showing the variation of the interface, so that we have in some cases, most of the cases, an increase of salinity, but in some cases we have an opposite response. Finally, just to show you the high resolution of the airborne EM due to continuous improvement of technology or processing and so on. This is a case in Netherlands. in which we could compare our modeling, that is in the background, with electrical conductivity sampled in salt water, that are some boreholes that in Netherlands are used in order to monitor the seawater encroachment. So the value are recorded by the black dots along any boreholes, okay? And we used the same color scale. So you can immediately see the very good agreement. For example, here we have a perfect overlap between our conductivity, resistivity, and the value measured in the salt water, yeah, for fresh water, and of course also for salt water. Yeah, we have also here, and we have also a good agreement for the brackish one, for the green one. Look, this is a profile parallel to the coast. These four are orthogonal to the coast. 1, 2, 3, 4. While this is parallel. So this is a very good example. So essentially, in conclusion, we can say that airborne EM could be considered a very useful method in order to face problem of coastal seawater encroachment due to the many advantages that I showed before. Thank you very much.
Thank you. Thank you, Antonio. And we also experienced the same methodology in the Neretva plain, so we really have the possibility to check the advantages of this kind of geophysical application. So now we move to the last intervention, that it is provided by Thea Ivanisevic from the JS. So Thea, okay. Hi.
Good afternoon to you. Good afternoon to everybody that are on the premises and that the other participants that are online. Can you hear me?
Yes. So thank you, Thea, for your intervention. She is the program communication manager from the JS, so she will say something about this important part of this project related to communication. So thank you, Thea.
Thank you so much. First of all, I would like also to thank the Veneto region representative for this new project, SeCure. Valentina Bassan, who invited me to your event. We have already spoken about the communication during our info session that we have organized in November online for the potential beneficiaries that were supposed to present their application forms to be financed by the program. However, I took this opportunity offered by Valentina just to remind everybody of you, even now when you have, I suppose, all the partnership participating to this event in person or online, and also when you have designated the communication manager of the project and the web content manager. So I won't take much of your time. Okay, I will just try to share my screen to show you some relevant parts in relation to the communication. Just please let me know if you can see it.
Yes. Yeah. Yes. We can see it.
Okay. Thank you so much. So I will put it in this modality so that you can see it better. Just a couple of slides because all the parts of your partnership are really already well experienced from the previous projects. So everybody knows, as also Valentina pointed out, more or less the communication requirements that the program has set from the projects that are taking over from the regulation, the European regulation, valid for this programming period 14-20, and also what also the program has set for the communication requirements. So just a couple of slides to remind you about some, according to the program and myself as a program communication manager, important issues. So your project is much about the communication, right? Because you are working together basically to showcase thematically what's been done. So what are we expecting from you is to start the project communication already since the beginning of the project. So from today, basically, and communicating all the activities now that you are setting up to give the birds to this cluster. So I also do communicate the activities you are performing to give life to your cluster. So the next slide, that it's really important to underline the content of this slide, is just to clarify what we expect. So we expect from you not to communicate the previous project results singularly by themselves. And that's what's been accomplished by every single project participating in the cluster and bringing its own outcome. Because they have already used the funds from the previous projects to communicate their project results. So now, basically, the communication of the cluster arrives when you have created this new cluster. And this means right now, as soon as possible, because you have only 15 or more or less months of project duration. So you need to be very quick on that. So the purpose of the communication of the cluster is that you, of course, take the previous project results, then you remodulate them by the means of the methodology that you will that you are going to set up among your partnership, and then that you identify, this is really important, a common element of your cluster. Then you start to communicate the thematical cluster of Italy-Croazia program. So this means you have to identify a common element. I think that you have already done that on your project while you were writing down the project and presenting the application form. So just identify quickly the methodology to collect everything that has been done and find the best, identify the best common element that connects all of you, that can communicate the thematical cluster of Italy-Croazia. So the purpose is of you to be the reference point in the areas for specific thematic for the specific thematic you are treating in the project, and to address the specific target groups to help them with their new work. So with the clusterization, you will identify new applications, new innovative actions that can be helpful. Of course, what I wanted to also to underline that needs to be, how can I say, defined immediately, because it can influence the type of the communication you are going to make, is that you will decide, and you need to decide if this initiative, so your project, is going to gather everything, remodulate and communicate the cluster of the program, or whether you are going to decide that you are going towards the formalization of new entity, consortia, or that you will use to communicate the essential part of this cluster. In the first case, if it's the first case that I have mentioned, then you are going to communicate everything as a cluster of the program. In the second case, whether you decide to create by the means of memorandum of understanding, formalizing some cluster that will group the organization and so on the Adriatic level, then you need to move in this direction to choose the right name, and then you will communicate this kind of cluster activity, I mean. Also, what is important to remind, and what you have been, how can I say, qualified and evaluated for, is also the fact that you are going to try to connect with similar projects that are treating the same thematic that are the strategic ones. So this is an added value for your communication activities, and that can certainly help you not to reinvent the wheel, but act like a thematic horizontal community. So I think that these are pretty much important distinctions that you need to start to think about since the beginning, since your kickoff event is starting. And I wouldn't go too much in other mandatory activities which you already know and you have indicated in the application form. I would like just to remind that we have required also the digital editorial plan to be sent to us as soon as possible after your project start, because this will help us also as a program to connect with you and with your activities, but it means that you need to, starting from this moment, to be very aware of what are you going to perform in terms of communication activities like events, production of excuse me, specific formats. So when I say this, I mean we are going to produce a video, we are going to produce these infographics that are going to treat this kind of topics addressed to some specific target groups and with the approximate deadline, because this is really important now for us as well, when we have as a program a support of an external service provider that facilitates the work of communication and that can also support this synergic connection among the program and among the projects. So basically, this is it as it concerns of my presentation to you. I wanted just to underline also, because today I've sent a communication to everybody that we have finally defined and uploaded the communication kits for your projects. You can find them on Italia-Croazia Docs and Tools section dedicated to project implementation that I assume that you can see down here for your project. We have uploaded all the elements that you will need for your constant communication, both online or hard copy papers and so on and so forth. You've been also put at disposal your project website. This is SeCure, and it's available here. So you can use it, and we ask you kindly to use it constantly for your communications, especially for all the informations that concern these activities that I've said before, that are giving birth to your cluster. So we're setting up, how do we work? Everything is interesting to know, because in the cooperation, also working together, building together something, in this case cluster, even this represents an activity that needs to be accompanied by your communication activities. So the starting point of your communication should be your project website, where you will announce periodically some relevant articles as news, or events, like in this case, please, also the kickoff event has not been set, but you can add it later on. And for any other events starting from your page, then you go to then you can go to promote furthermore among your stakeholders, among the thematic community, the events that you are going to organize, that you are organizing, the registration and so on. Because the most important thing is that you favor stakeholders to come to visit your project webpage that needs to be constantly updated, full of content, also in a library. As soon as you develop some applications, some new tools that is foreseen by your application form, do communicate them, but always please do this starting from the web page. Then you can use other channels like social media campaigns, but the purpose is to bring the stakeholders to your project web page, which is your project home. So I hope that that is clear, that I have cleared some potential doubts that you might have. And I am available for any of your questions if you might have it.
Thank you, Thea. Thank you a lot. I think that probably we will have still some doubts, but probably I think that this afternoon we are quite let's say late and also tired, because it is really a long day. Yeah. But I think that we will for sure report to you again. We have already, let's say, nominated our two managers related to communication, and they will be for sure in contact with you in order to clarify some points that we have highlighted. So thank you so much to contribute, and we will for sure keep in touch during the next days and weeks.
I have received an email. I haven't managed to reply yet, but I'm of course at your disposal for any further exchange. It's important that you remember these initial things that I've said, to communicate as one and thematically, because you will represent the reference point for this thematic that your project is treating, okay?
Yeah.
On all the area of the program.
Okay.
So,
okay. Thank you so much.
Thank you so much for inviting me.
Okay, so I think we can close, because Valentina is continually told me we have really to close because we have a bit in a hurry. So I think that we can thanks everybody here that followed the event here. We thanks a lot the speaker that we have also remotely connected, and also that follow the event. So thanks to follow this event, and I give you the microphone to Valentina for the update, what we have to do now.
We have the guide for the tour of Venice that are waiting us at 5 o'clock at the exit of this. Now. We see, yes.
Okay, so we can, Francesco. Okay, so Thea, see you. Thanks a lot.
Thank you again. See you soon. I'm so sorry that I'm not with you for a guided tour, but I hope that we will meet soon in this wonderful premises in which we have organized so many events. So many best wishes to everybody. Thank you. Bye-bye.
Bye.